Hi, this is Mrs. Young, and today's lesson is a continuation of our review on the functions unit. So yesterday we started reviewing the functions unit, and today we're continuing this review of the functions unit. So right now I'd like to go ahead and check your homework answers. So go ahead and open up your packet to page 36. This was your homework for last night. If you did your homework electronically, you might want to pull that up and check that as well. Or if you have the packet, you can open it to page 36. So again, just kind of going over our homework from last night. The first section, 1 through 7, you had to say whether it was a function or not. So number 1, we said yes, it is a function. Your explanation could be that there's no repeated x values, or you could say that each input has its own or unique output. Number 2 is not a function because there is a repeated x value of 2. Or you could say that the input of -2 has 2 different outputs, right? Number 3, again, no, not a function. And I would say because it does not pass the vertical line test, I can see that if I drew a vertical line there, it would intersect the graph in more than one point. Number 4 is a function. It does pass the vertical line test. Number 5 is not a function because the y variable is squared. And number 6 is a function because the y is not squared, or you can say that each input has its own outputs. Number 7 says to give an example of an ordered pair that, if added to the set of ordered pairs in number 1, would make the set not a function. So you want to give me an ordered pair that has a repeated x value. So you want to give me a ordered pair that has an x value of either 6, 7, 8, or 9. So I just randomly chose 6, -1 as an example. But again, your answer could look different than mine as long as you have an x value of 6, 7, 8, or 9. The next section of your homework was comparing the functions, comparing their unit rates or rates of change or slope. So in function 1 here in number 8, 5, 6, I used my calculator. 5, 6 is about 0.83. In function 2, when you have a table of values, you use your slope formula to calculate the slope, and I have a slope there in function 2 of 0.75. So again, when we are comparing their slopes or rates of change, I can see that function 1 has a bigger slope. So function 1 has the greater rate of change because 5, 6 or 0.83 is greater than 0.75. Again, when your equation is in slope-intercept form, the number in front of the x is your slope or rate of change. When they give you a table of values, you use the slope formula to calculate your rate of change or slope. Number 9, I actually did with you in the previous video. We put the equations into slope-intercept form, and when we compare those slopes, we can tell that function 2 has a bigger rate of change because 2 is bigger than 2/5, or 2 is bigger than 0.4. And then on to the last part of our homework. There are 2 more problems on the next page, on page 37. So number 10, Carly eats 3 gummies every 15 minutes, 3 gummies per minute. And then the graph represented by Jill, so I can see I'm going down 4 and to the right 30, right, to the right 30, down 4. -4 over 30 reduces to -2/15. So -3/15 and -2/15, who's eating gummies at a faster rate? Well, clearly, if Carly is eating 3 gummies for every 15 minutes, and Jill is only eating 2 gummies for every 15 minutes, then Carly is eating gummies at a faster rate. 3/15 is greater than 2/15. And then finally, in number 11, in the equation for New York City, the slope is the number in front of the x value. So my slope there is 0.4. For San Francisco, we have a table. So I take the first 2 ordered pairs and plug them in for my slope formula and get a slope or rate of change of 0.45. So the rate at San Francisco is 45 cents per mile, and the rate in New York City is 40 cents per mile. So obviously, the higher rate, the greater rate is San Francisco because 45 cents is bigger than 40 cents. So that was a quick review of our homework from last night. And today, since we're continuing our review, we're going to go back and continue taking a little bit of review notes on page, I think this was page 35. So turn in your packet to page 35. If you don't have room on page 35, you can use the back of the packet or your own scratch paper just to write down a little bit of notes here on a review of lessons 3 and 4. So previously, yesterday, we reviewed lessons 1 and 2, and then now we're going to take a little bit of notes reviewing lessons 3 and 4. Okay, so for lesson 3, again, taking a little bit of notes here on our review. For lesson 3, the topic here was telling whether a representation was linear versus nonlinear. Is what I'm looking at the relationship linear or nonlinear? And we looked at 3 different representations. If we looked at a graph to know if it was linear, we just check to see, is it a straight line? If it's a straight line, then it's linear. Remember that it's got the root word line, right? Line, linear, straight line. That's how I remember. And then if it's nonlinear, it's not a straight line. Not a straight line. And when we talked about this a long time ago, we actually looked at a bunch of graphs. So I'm going to just draw you a couple of sketches of graphs of ones that are not linear. So like a real common one when you get to algebra is like a parabola or U-shape, right? And then another one that you might see in algebra, it's the graph of an absolute value function. So it's kind of a V shape. So those are all ones that are not linear because they're not straight lines. So if there's a curve or bend in it, then it would be nonlinear. So again, that's if we're looking at the graph. That's pretty easy. What if we're looking at the equation? If we look at an equation, how do we know if it is linear or not linear? So if the equation can be written in the form y equals mx plus b, if we can put it in that slope-intercept form, then we know that it must be linear. The way that I know that it's not linear, one thing that I look for is an exponent on the x variable. Remember that an exponent on the y variable makes it not a function, but an exponent on the x variable makes it not linear. So here's a couple examples, like y equals x squared. Again, that would look like a U-shaped parallel. That wouldn't be straight. Or another example would be like if I had y equals, let's say 2 over x. Remember, to take that out of the denominator, we take the reciprocal, so that'd be x to the negative 1. So that would have a variable on my x variable, an exponent on my x variable. So those are both examples of equations that are not linear. And then our third and final representation was when we looked at a table of values. And when we look at a table of values, what we're looking for it to be linear, is a constant rate of change. Constant rate of change. And for it to be nonlinear, you're looking for there not to be a constant rate of change. Not a constant rate of change. And I'm going to show you an example here. When you're looking at the table of values, it might even help to have a calculator handy if the numbers are a little crazy, but I'm going to give you a pretty simple example here of a table of values. So again, in my table of values, I'm going to put my x values on top and my y values on bottom. So one ordered pair, let's say I have an ordered pair of 0, 4. And then let's say my next ordered pair is 1, 7. And then let's say my next ordered pair is 2, 10. And then let's say that my last ordered pair is 3, 15. So in this table of values, trying to tell if it is linear or not, I notice that my x value from 0 to 1, that goes up by 1. From 1 to 2, that goes up by 1. 2 to 3, that goes up by 1. So that is going up at a constant rate in your x values. Now, if you look at your y values, when you go from 4 to 7, how much does that go up by? Again, these are pretty simple numbers, but if your numbers are a little bit more complicated or different, you might want to use a calculator, because if I just take 7 minus 4, I get 3, so that goes up by 3. If I take 10 minus 7, that goes up by 3 again. But if I take 15 minus 10, that last one goes up by 5. So I can see the y values are not going up at a constant rate. So this is non-linear, right? So that's not linear. So again, whether I look at an equation, a table, or a graph, I should be able to determine whether it's linear or non-linear based on what I'm seeing. And then the next thing that I wanted to do a quick review on was lesson 4. The topic in lesson 4 is writing equations. Oops, writing equations from tables or graphs. Can you write an equation given a table or a graph? So I'm going to start with the one that I think is the easiest, and that's the graph, because we did this actually in a previous unit. So I think trying to write an equation from a graph for you guys should be easy because it is something that we have seen before. So to write an equation from a graph, the first thing you do is you find your y-intercept. Find the y, where it crosses the y-axis, where the line crosses the y-axis. That's your y-intercept, that's your b-value. And then the second thing you do is you find your rise over run, make your slope triangle to get your slope or m value. And then you take those two values and then you can write your equation, in slope-intercept form, y equals mx plus b form. Again, that goes right back to our last unit that we had, where we looked at a graph and tried to write the equation. So I'm just going to show you a quick little example here of a graph, and we're going to try to write the equation. So I can see in that picture that it's crossing the y-axis right there at 2. So my b-value, or y-intercept is 2. And then I can draw my little slope triangle, right? Rise 1, run 2. That means that my m, or slope, is 1 over 2, rise over run. So if I want to write the equation of that graph, I would say y equals 1/2 x plus 2. Again, all I'm doing there is plugging in my slope and y-intercept into the slope-intercept form. And again, you have done that before, so that should be relatively easy. Then the other thing that we did, and this was a little bit new for us, is how do I write an equation if I'm given a table of values? So if you're given a table of values, well, the one thing you do know how to do is to find your slope, and you can find your slope by using the slope formula. y2 minus y1 over x2 minus x1. That'll give you your m, or slope value. And then the second step, and this is maybe a little tricky, or maybe we haven't talked about this too much, is that you want to look for the x value of 0, and then the corresponding y value will be your y-intercept. So you look for in the table of values, look for an x value of 0, and whatever that y value is, that will be your y-intercept. And again, once you have the slope and the y-intercept, then of course you can write your equation in slope-intercept form, just like we did for the graphs. So I'm going to show you a picture of a table. There's a little table I made, and I want to try to write the equation for this table. Again, the first thing you're going to do is find your slope using your slope formula. So I'm going to say that -1 is my x1, 4 is my y1, 0 is my x2, 2 is my y2. And I'm going to go ahead and plug the numbers into my slope formula. So y2 minus y1, 2 minus 4, over x2 minus x1, 0 minus a -1. Well, 2 minus 4 is -2. 0 minus a -1, remember those cancel out, that's really 0 plus 1, which is 1. So this gives me a slope of -2. That's my m value. Then trying to find my y-intercept, if I look at that table, here's where my x value is 0, and that corresponding y value is my y-intercept. So 2 is my y-intercept. So now using these values, I can write my equation. I can say y equals -2x plus 2. Y equals -2x plus 2. There's my equation in slope-intercept form. So again, you look for an x coordinate of 0, and that y value is your y-intercept. Think about it. If you graph 0, 2, well, gosh, I'll go up here, 0, 2, right? That's a point on the y-axis. It's where the line is crossing the y-axis. So that's a quick review of lessons 3 and 4. For homework tonight, we're going to go back to where I was going over my homework before. So go back to page 37, and your homework is going to be page 37 and 38, 12 through 20. 12 through 20 on pages 37 and 38. You can see that the first part of this assignment is telling me whether the equations are linear or not linear. Equations in 12 tables in 13 and 14, graphs in 15 and 16. And then the second half of this assignment, 17 through 20, is going to be on writing equations given tables or given graphs. So everything that I just reviewed in those problems 12 through 20. So make sure you get the assignment done, and then make sure you get it turned in to me. Thanks, guys. Stay healthy.